to find the y value of the function. So if you can imagine the inverse, and this is the inverse of our function with y as a subject. And when we write the final answer, we make y the subject, and we need to find the fifth root of that. And that is just, so if you don't know that, I'd like you to go back and look at that table and memorize that completely before we keep going. We see that x has to be between 0 and 1. So we worked out the domain to be between 0 and minus inverse cosine of a. So that negative inside becomes pi minus. All is positive there, sine, tan, and cos are positive in those respective quadrants. So if cosine is that x equals to a, so therefore from this here, by letting it equal to x, and then, now why we've listed these ones on the board is because they're going to be used in each of the questions. So I think that's quite easy to remember because for both of them, cos is the one that we need to be careful of. Alright, let's work with these symmetries and making the tangent of both sides. I worked out that tangent alpha plus beta equals to 7. But what we need to be careful of is we know it's going to cross the x-axis in between our two values. So same with sine, I can't help you any more than saying remember that shape, and it kind of looks like the flip, but there's no equal to, right? Because there's asymptotes. So be really careful when you do write that in. Spend a minute now just memorizing your general solution, because the best way for you to memorize something before the exams is have come across it multiple times by using your trigonometric formula here, okay? So I think that's really good to know. That's why we have a square root 1 minus x. Remember that sec squared equals to 1 plus tan squared, yeah? So that is your second problem. So applying this formula, have 1 on a, and then have inverse tangent of x on a here, yeah? And don't forget you're multiplied by your